Hi, good morning students. Welcome to my channel. Now I am starting the fundamentals of physics. This is class number 3, dimension analysis. Okay. First doubt will come into the mind. What is meant by a dimension? Dimension has some special meaning in the physics. Dimension means it denotes the physical nature of a quantity. Okay, what is physical nature? Again, it is a dot. I will give some example. Take a distance. Distance we can measure in meter, kilometer, feet, fathom. Different units are there, but ultimately we are measuring one particular quantity. That is called dimension. So dimension of a distance is length. Okay. Similarly, mass also one dimension, time also one more dimension, and length. Mass, length, time. These three we use normally to write a dimension of a derived quantities. Okay. So we use some symbols for mass, capital M, length, capital L, time, capital T. Okay. This M, L, T, we should write them in capital and they should be non-italic. Okay. This is some standard way of using these symbols. Nothing special in that. Everybody throughout India, throughout world, normally we use these symbols M, L, T in capital and non-italic. Nothing harm to use that. Okay. Then what are the dimensions of some derived quantities? Okay. Just like take velocity, what is its dimension? Acceleration, what is its dimension? And force, what is its dimension? Work, what is its dimension? Okay. That particular derived quantities dimension we will do now. I will show the dimension of these derived quantities. See here, this is velocity. Velocity I am writing in a bracket. What it represents? The dimension of velocity I am asking. So it is equal to displacement by time. Displacement is nothing but length. So L by T. So LT minus 1 is dimension of velocity. Similarly, you go for acceleration. Acceleration is equal to velocity by time. So this is L by T square. This is L T minus 2. So dimension of acceleration is LT minus 2. Now you take one more example. Force. F is equal to ma. M is the mass. A is the acceleration. So ml t minus 2. This is the dimension of force. Similarly, you take for work. W equal to F into S. F is the force. S is the displacement. So ml t minus 2 into L. So finally you will get ml2 t minus 2. This is dimension of work. You take power. Power is equal to work by time. W by T. So this is ml2 t minus 2 divided by T. Finally you will get ml2 t minus 3. Okay. So this is dimension of power. Now you understand how to write dimension of derived quantities. Okay, you have seen the dimension of derived quantities. Now we will discuss what are the applications of dimension analysis and what are its limitations. First I will talk applications. By using dimension analysis, we can find the relation among the different quantities. Just like the relation among displacement of the particle, acceleration and time. That we will derive in the next continuous. And another one, we can check the given equation is correct or not by using dimension analysis. Okay, these two applications are there. The limitation is we may get the relation among the quantities like displacement, acceleration and time, but we cannot find out what is the constant involved in that. Okay, now we'll see some relation between the displacement and acceleration time. Okay, you see forward. Okay, see here, this is one of the example. This is x, the position of the particle, proportional to a power m and t power n. A is the acceleration, t is the time, m, n are two constants. Then x is equal to some k into a power m into t power n, you can write. K is some constant. So we can check what relation we will get by using dimension analysis. X is the displacement, no? So its length, its dimension is L power 1, t is not there, no? So t power 0, t power 0 is 1 only. This is k is constant as it is, you write, no problem. For acceleration, what is the dimension? Lt minus 2, already we derived. All to the power of m, same m you have to write. T is the time, so t power n. So you open this bracket, L power m, t power minus 2m into t power n. Now what you will get? L power 1, t power 0 is equal to k into whatever, L power m, t power minus 2m plus n, no? Both the side you equate powers of same dimension. Length dimension here, m is there, no? M is equal to 1. Okay, here time, what is the power here? Minus 2m plus 1 equal to what? 0. So minus 2m plus n is equal to 0. So n equal to 2 you are getting. M equal to 1, n equal to 2. What relation you will get? X is equal to k into at square. So we are getting this relation is very good. But this k, no, we cannot find out by using dimension analysis. This is limitation of dimension analysis. Okay, we'll go for other. We can check whether given equation is correct or not. Okay, this is velocity, v equal to u plus at. V is some final velocity, u is initial velocity, a is acceleration, t is time. So we know the dimension of velocity Lt minus 1 is equal to Lt minus 1. This plus you need not to write, just I am writing. Acceleration Lt minus 2 into t. So here t minus 2, t power minus 2, this is plus 1, no? Lt minus 1 it will become. So dimensionally, this all three quantities have the same dimension, Lt minus 1, Lt minus 1, Lt minus 1. So this equation is correct. Okay. By dimension analysis, we can tell that this equation is correct. Now we will see other equation. This is s is equal to ut square plus half at. S is displacement, so length. U velocity Lt minus 1 t square t plus of this constant I am not writing. It is not required. Just we have to write dimension only for the quantities acceleration and time. Acceleration के लिए Lt minus 2 time t. So what you are getting? This is L into t. This is L into t minus 1. So this dimensionally not correct. So this equation is wrong. You understood, no? Okay, students. I think you understand what is dimension analysis, what are its applications, what are its limitations, how to write the dimensions for derived quantities. Okay. Now I am finishing this video for this dimension analysis. Next video soon I will put. The topic will be significant figures. Till then, bye bye.